Alright guys, so we are going to continue to talk about similar figures outside of the coordinate plane. And we're going to talk about how to determine the scale factor of two figures that are not on the coordinate plane and the relationship between the sides. And we're going to talk about, well, you already know what these key vocab words are. Um, a dilation is when you make things bigger or smaller. A reduction is when K is less than 1. An enlargement is when K is greater than 1. A scale factor is what the K is, and it's what either the lengths of the sides are multiplied by or what the coordinates, if it's on the coordinate plane, are multiplied by. And corresponding sides are matching sides in relationship to where the sides are in the figure. And I can show you that more. So go ahead and write these words down. And you already know the definition, so you can just type them in or write them in your book creator. Okay, so here the question says, determine if the figures are similar, show your work. So we need to figure out if these figures are similar or not. And because it didn't give us any angles, we have to find another way to figure out if these figures are similar. So the definition for similar figures are what is, and I'm going to write the definition down here. So the definition says that the ratio of the corresponding sides are equal, are, and the corresponding angles are equal. Okay? So that's the definition of similar figures. But if we go up here, we don't know anything about the angles because it didn't tell us anything about the angles inside. But it did give us three sides. So we can kind of deal with the first part of this definition. And then if the first part of the definition works, then we can assume that the second part of it will work. And that's based off of our theorems, which I think we learned on yesterday. Okay, so my job here is, since they gave us sides, I want to try to highlight the sides that correspond to to each other. 84 is the longest side of the big triangle, so the other longest side would be 14. So those sides match. Okay, 48 is the next to the longest. Hmm. All right, so here we're going to say that this 48 matches this side right here. Okay, so 48 is the smallest side of the of this triangle, so it's going to match the smallest side of this triangle. And then I'm going to put this in blue. 72 is the next to the largest side, so it's going to match the next to the largest side of that triangle. Okay, so you match the big side of this triangle with the big side of that triangle, and then you match the next to the big side with the next to the big side in the other triangle, and then you match the smallest side with the smallest side of that triangle. So that's another way of looking at it. So this is the big side matching the big side. We'll call this medium side matches the medium side, and then small side matches that small side. So, and that's what we mean by corresponding parts. Okay, so since they only gave me sides, I have to look at the first part of my definition for similar figures if I want to figure this out. It says the ratio of the corresponding sides are equal. So here it says determine if the figures are similar and show your work. So now I need to say will the ratio of the corresponding sides actually equal? So I'm going to do, and I'm going from from left to right. I have to make sure I keep my ratio together. So I go 84 over 14. And that should equal, now I'm going to go to my medium side, 72 over 12. And then I'm going to go to my small side, 48 over 8. And look, I went from left to right, left to right, left to right. Okay? So now we just need to do the math. So what you can do is you can go to Desmos. Let me show you that. Do I have Desmos here? No. So you can type in Desmos scientific calculator, and it's on the PDF as well. And then I'm going to go break down those fractions. So this is my ABC key, and it was 84 over 14, which is 6. All right. So this equals 6, and I'm going to write it down here, guys. I need room. Or I'm going to just write it smaller. Give me a second. I want to make this neater. So 84 over 14, that equals 6. And what did we have? 72 over 12. Well, I know that off the top of my head, that is 6. And what was it? 48 over 8. And I know that off the top of my head is 6 as well. So I have here where it says determine if the figures are similar. Well, the first part of my definition says that the ratio of the corresponding sides are equal. So when I did these ratios, I got them all to be equal to 6. So are they similar? Yes. Because the ratio of the corresponding sides are equal. So the answer to this would be yes. And that's because the ratio of the corresponding sides equal. All right, so you good on that. So therefore we can assume that, guess what, this angle right here is the same as that angle, because the definition said corresponding angles also equal. So the angle in this position equals the angle in that position, and the angle in this position equals the angle in that position. So I can say those angles are equal since I found that the ratio of the corresponding sides are all equal. Okay, now it says if the triangles are similar, give the similarity ratio. Well, here we go. I'm sorry, the similarity notation. So we need to say these are triangles, so triangle, and I'm going to start here. CA, that's my red line, so C to A, and then I'm going to go from A to B. So triangle CAB. So CAB. So I went from the red side, which is called side CA. Then I went to the blue side, which is called side AB. And then I went to the yellow side, which is called side BC. So CAB is similar. That's the notation for similarity. Similar to triangle. Now I need to do the same thing. I need to start with the red side, F to H, and H to G. Okay? And that's my similarity notation. And now it asks me, what is the scale factor? Well, if you notice up here, and if we go from left to right, you can write the scale factor in 2 ways. If they don't tell you a direction, then you can automatically read from left to right. So we know here that since I went from a big picture to a small picture, my K needs to be less than 1. So if my K should be less than 1, that means I need to do small over big. So you choose one of the matching sides. So I'm just going to go with the red corresponding sides. So I'm going to say that K equals 14 over 84, which is equal to 1 over 6. So my scale factor here is 1 over 6. So if you're not told to go from big to small, then just automatically read it from left to right, and I'll be able to grade that way. All right, so I want you guys to try your homework problem out, and then I'll see you in class on tomorrow or whichever day we do our rotation on. Bye, guys.